In this video, we're going to discuss how we divide polynomials. We're going to start with the simplest case, which is dividing monomials by monomials. This is going to be very similar to how we multiply monomials by monomials, except for we're going to have our operation be division. So we're going to divide the coefficients, and then we're going to divide the variables. All right, and we're going to look at this example where we have a monomials in several variables: 40x cubed y to the 11th divided by 8xy squared. Notice it says divide, assume no variable is 0. Of course, if x or y in this denominator is 0, then we would have an undefined term. So that's the only reason why I have this piece right here. Remember, 0 is that number that we can't divide by. It is considered to be undefined. But if we look at this example here, if I wanted to do this division, I'll do the 40 divided by 8, which is 5. And you have to remember that when you're dividing and your bases are the same, you subtract your exponents. So I have x to the third, and remember there's a 1 understood to be there, and I'm going to write this out. That'll be 3 minus 1 times y to the 11 minus 2. Of course, we can simplify those further. 3 minus 1 is 2, and 11 minus 2 is 9. So I will get 5x squared y to the 9th. That is a 9 there. All right. That's dividing two monomials. That's the simplest case. Now what we want to do is divide polynomials by monomials. All right. And this is going to be similar to dividing a polynomial multiplying a monomial and a polynomial. Every term, remember, we use the distributive property so we can distribute that monomial to every single term in that polynomial. Well, the same thing is going to happen here, except once again we're having a division. That means every term in this numerator is going to be divided by that single monomial in that denominator. And so we could rewrite this as 36x to the 6th over 5x to the 4th. I'm going to keep that same sign. That'll be 40x to the 5th over 5x to the 4th. And then minus 5x to the 4th over 5x to the 4th. And of course we can simplify. Notice here, 30 divided by 5. 5 doesn't go evenly into 35, and they don't have any common factors. So I'm going to leave that as 36. I'm going to leave that as 36 over 5. And remember, with those exponents, when the bases are the same, you subtract those exponents. And so if I do 6 minus 4, I'm going to get 2. So I get 36 over 5 x squared. Minus 40 over 5 is 8. Again, I subtract my exponents. I get 5 minus 4, which is 1. Remember, we don't have to write that 1 on the exponent on that x. And then over here in our last term, I have 5 divided by 5, which is 1, and x to the 4th divided by x to the 4th, which is 1. And so everything cancels there. Remember, it's not 0, it is 1 when you cancel, when you have multiplication and division. And so my polynomial here is going to be 36 over 5 x squared minus 8x minus 1. Before we get to dividing polynomials by polynomials, I want to review how we do long division, because that is the method that we're going to use to divide polynomials by polynomials. All right, bigger than monomials, longer than monomials. All right, and so I'm going to look at this first example where I divide 186 by 6. Remember, when we do long division, our 6 goes on the outside, our 186 goes under our division symbol. And here we say, how many times does 6 go into 1? Well, it doesn't go into 1, and so we say, oh, well, how many times does it go into 18? All right, instead of saying how many times, what I'm going to do is I'm going to say, what can I multiply this 6 by to get as close as possible to this 18? And the same thing would be the case. It would be 3, right? And after I write my number up there, I go back and I multiply that 3 by the 6 here. 3 times 6 is 18. Write it down there. And the operation I do next is subtraction. 18 minus 18 is 0. And then we bring down our next term, which is the 6. Now I start the process over again. How many times does 6 go into 6? Or another way to write it, what's the largest number that I can multiply 6 by to get as close as possible to 6? And you would say 1. Okay, and then once I write my number up here, I'll have 1 times 6, which is the 6 that is sitting here. And then you do the subtraction and you get a remainder of 0. All right, and so we can say 186 over 6 equals 31. All right, remember some important terms. This is called our quotient. This is our dividend. This is our remainder. And the 6 here is our divisor. Okay? And so if our remainder is 0, then our solution is just our quotient. I'm going to abbreviate that with Q. All right? Let's look at this next example. We have 195 divided by 6, and we want to figure out what that is. So once again, I'm going to take my 6. It's my divisor. 195 is my dividend. And then again, I'm going to ask myself, well, how many times does 6 go into 1? Or what can I multiply 6 by? A whole number, right? That I can multiply 6 by to get as close as possible to 1. And you say 0, and we don't normally write the 0 up here. And so we add the digit 9. What do I multiply 6 by to get as close as possible to 19? And we would say 3. And then what we're going to do is once we write our answer up here in our quotient, we multiply the quotient part by our divisor. 6 times 3 is 18. I'll do the subtraction and I get a remainder of 1, but we're not done. We have to bring down our next digit. Now we start the process over again. What can I multiply 6 by to get as close as possible to 15? And we would say 2, because 6 times 2 is 12. Do our subtraction, we get a remainder of 3. And we have no other digits. And so one way to write our answer is to say that this equals 195 over 6 equals 32 and 3 over 6. Of course, 3 over 6 is the same thing as 1/2. So it's 32 and 1/2, right? And that's how we leave our answer as a mixed number. Remember, when we write mixed numbers, this is the same thing as saying 32 plus 1/2. And so one way to write our answer is to write it as our quotient plus our remainder over our divisor. All right, that's one way to write our answer. So let's do this, but let's do it with polynomials. But the same process that we used in this example and in this example here is going to apply. Let's look at the example. All right. Before we get into the example, I want to look at some things that you want to remember before you actually start your long division. One of the things you want to remember is to make sure that all of your terms are written in descending order. And what I mean by descending order, again, is that the highest exponent is first, followed by the next lowest exponent, followed by the next lowest exponent, so on and so forth. All right. For instance, in this example here, I have an x squared, and then I have just an x to the first power, and then I have my constant term. That is written in descending order. This denominator is as well. The second thing I want to remember is that we're going to fill in zeros for missing powers of x, and we'll see examples like that in class. So let's look at this example using long division. All right, my divisor here is x minus 4. Remember, whatever's on the bottom is your divisor. And my dividend is the numerator. And when I do this long division, there's one difference between this, when we do long division here versus with numbers. When we did just the regular numbers, we'll look at the whole divisor and see how many times it goes into the digits here. When we're looking at long division of polynomials, we're only going to look at our leading term, all right? So I want to say how many times does x go into x squared? Or another question that I can ask is what can I multiply x by to get as close as possible to x squared? And my answer there will be x. Now I'm going to write my x in my quotient right here, just so it lines up with the x terms that are here. That way when I get to the end, which is this column right here, I know I can stop my long division. All right. You can write it here because x goes into x squared x times. But again, I'm just going to write mine here so that things can line up so that when I get to here, I'll know that I can stop. All right. All right. But anyway, we're going to continue with our long division. Once we write something in our quotient, The next thing to do is to take that number and multiply it by my entire divisor. So this is when the entire divisor comes into play. So when I multiply this x by that x there, I'm going to get x squared. And when I multiply this x by this minus 4, I get a minus 4x. My next thing is to subtract. Now, I'm going to put this in parentheses here, and the reason why I'm doing this in parentheses is because I not only have to subtract the x squared, I also have to subtract this negative 4x. And so when I do x squared minus x squared, they actually cancel, and that is always going to happen. Now what I have to do is this negative 3x minus this negative 4x, right? Remember, I'm subtracting a negative 4x, right? In other words, that's going to be like adding, and I'm going to use a different color here. It's going to be like adding 4x there, all right? So that's going to be like a negative 3x plus 4x, which is a positive x. All right, so I know that can be confusing, but you have to remember that subtracting is the same thing as adding the opposite. I'm not done. I'm going to have to bring down my next digit, which is that minus 52, and then I start that process over again. I want to ask myself, what do I multiply x by to get as close as possible to x? Well, anything times 1 is that anything, and so it's going to be a 1, and it'll be a plus 1 since it's positive. Remember, every time I write something in my quotient here, I go back and I multiply it by both terms or everything in my divisor. So I'm going to have a 1 times x and a 1 times negative 4, which will give me an x minus 4. Remember, once I write it under here, my goal is to subtract again. Notice here, I'm subtracting not only the x, but I have to subtract this minus 4. All right, so x minus x, they cancel. And remember, when I subtract this negative 4 here, subtract negative 4, that's going to be the same thing as adding 4. And so what I'm really doing is a negative 52 plus 4, and negative 52 plus 4 is a negative 48. And I'm done there. That is my remainder. And so one way for me to write my solution, remember we do our quotient, which is here, plus our remainder over our divisor. And so I can write my solution as x plus 1 plus negative 48 over x minus 4. Now, if you look here, this is a negative divided by a positive in a fraction. When I have a negative divided by a positive, I don't have to just write that negative on the outside here. I can bring it in front of this fraction and write it as a subtraction. And so it might be easier or simpler to leave your answer as x plus 1 minus 48 over x minus 4. Okay? Let's do one more example of this long division because it can be complicated. It's just a bunch of steps, but you got to be able to follow. Let's look at this example here. I have 6x squared plus 17x minus 5 all over 2x minus 7. And in this example, I always make sure that everything is in descending order. This is in descending order, this is, and that is as well. So is my denominator. And so I'm ready to go ahead and set up my long division. I'm going to have a 2x plus 7, and I'm going to divide that into 6x squared plus 17x minus 5. All right? And now I'm going to start that process again, right? When I'm looking at what I'm going to be writing in my quotient up here, I'm only looking at here, right? What do I multiply this 2x by to get as close as possible to 6x squared? Well, I need to multiply 2 by 3 and x by x, so I get 3x. Again, I'm going to write it in this area here so it lines up with my x terms. Again, I'm doing that so that once I finish, I get everything lined up at the end, right? Once I write something in the quotient, I go back and I multiply it by both terms in my divisor. All right, I'm going to have a 3x times 2x, which is 6x squared, and a 3x times 7, which is 21x. I do my subtraction. 6x squared minus 6x squared, that is 0. They cancel. And then now I'm going to do a 17x minus a 21x. Remember, that's minus a 21, right? That's minus a positive 21. So you're actually subtracting 21 here. And so that's going to be a negative 4x. And now bring down my minus 5. Start the process over again. What do I multiply 2x to get as close as possible to negative 4x? I multiply it by a negative 2. Once I write it up here, I go back and multiply this negative 2 by this 2x plus 7, right? Negative 2 times 2x is a negative 4x, and negative 2 times 7 is a negative 14. Again, I do a subtraction here. And so I'm going to have a negative 4 minus a negative 4. Remember, when you subtract a negative, that becomes a positive, right? And so negative 4x plus 4x, they just cancel. And so we canceling here. And then I have a negative 5 minus a negative 14. Again, I'm subtracting a negative, which is the exact same thing as adding the positive. And so I will get negative 5 plus 14, which is 9. And so I can write my solution here. I have my quotient and my remainder. And so my solution can be written as, see here, 3x minus 2 plus 9 over 2x plus 7, right? And remember, this part right here is my quotient. This is my remainder. That's my divisor. R stands for remainder, D stands for divisor here. But that is long division, and that includes our study of polynomials, adding, subtracting, multiplying, and dividing.